Imagine a reality where time doesn't exist. No past, no future, just an endless void of nothingness. Hard to wrap your head around, right? Now try this one. How did time begin? Did it emerge from the Big Bang, or was it always there? Before we dive into the origins of time, we've got to ask, is time even real? We experience time every single day, the seconds tick by, minutes turn into hours, we celebrate birthdays. But what if I told you that, according to physics, time is not as absolute as it appears? Einstein's theory of relativity revealed that time is relative. Time doesn't flow at a constant rate throughout the universe. It's affected by gravity and speed. Imagine two clocks, one on Mount Everest and one at sea level. Time moves a tiny bit faster for the clock on Everest. If time can be stretched and squeezed, is it really a fundamental aspect of the universe or just a handy tool we created? Let's crank up the cosmic time machine and journey back to the very beginning, the Big Bang. 13.8 billion years ago, the universe was crammed into a point so small, so dense and hot, it defies our understanding of physics. Then, boom, the Big Bang. Space itself exploded outward, expanding faster than you can imagine. Before the Big Bang, there was no space as we know it. And guess what else? No time either. The expansion of the universe didn't just create space, it created time itself. Think of it like baking a loaf of raisin bread. As the dough rises, the raisins, representing galaxies, move away from each other. If time began with the Big Bang, then asking what happened before time began is like asking what's north of the North Pole. We've explored the idea that time began with the Big Bang. But what if that's not the only possibility? Some physicists believe that our universe is part of a much grander cycle, a cosmic dance of expansion and contraction known as the Big Bounce theory. Imagine a universe that expands, then contracts, then expands again for all eternity. In this scenario, time wouldn't have a starting point. It would flow eternally through each cycle of cosmic creation and destruction. Others theorize that our universe is just one of countless universes in a vast multiverse, each with its own unique experience of time. If the multiverse theory holds true, then time didn't begin with our Big Bang, it's just one dimension of reality we experience in our own corner of the cosmos. Are you ready to get really weird? We're about to dive into the quantum realm, where the laws of physics get thrown out the window. In the quantum realm, time doesn't behave the way we're used to. Some quantum physicists suggest that time might not even exist at the most fundamental level. When you look at a single atom, it doesn't have a concept of time. It exists in a state of superposition, defying our linear understanding of time. It's only when you observe large groups of particles that time seems to emerge. Some interpretations of quantum mechanics suggest that time is an emergent property, like temperature, a side effect of the universe's complexity. Time, as we experience it, has a very distinct direction. We remember the past, but the future remains a mystery. We can't rewind our lives no matter how much we might want to relive that epic victory or undo that embarrassing blunder. But why? Why does time have this frustrating one-way street policy? It's a question that's baffled scientists and philosophers for centuries. Here's the thing. Most laws of physics work perfectly fine in reverse. Imagine watching a movie of a single billiard ball bouncing around a table. Now play the movie backward. Would you be able to tell the difference? Probably not. The laws of motion work the same way forward and backward. But in our everyday lives, we see a clear arrow of time. Eggs break, but they don't spontaneously unbreak. People age, but they don't magically get younger. The universe seems to be moving from a state of order to disorder, and this tendency toward disorder is what physicists call entropy. The past is simply the low entropy state that we remember, and the future is the high entropy state we haven't experienced yet. We've explored the beginning of time, but what about its end? If time is a product of the universe, then its fate is linked to the universe's fate. If the universe continues to expand forever, becoming a cold, dark void, then time might stretch on indefinitely, but without much to mark its passage. One theory suggests that the universe's expansion could eventually reverse, pulling everything back together in a cataclysmic event called the Big Crunch. In this scenario, time as we know it would cease to exist. Another possibility is the heat death of the universe. As the universe expands and cools, eventually stars will die out, black holes will evaporate, and the universe will become a vast, cold, and empty place. In this scenario, time might lose all meaning as there would be no events to distinguish one moment from the next. Some theories suggest that at the end of the universe, time itself could undergo a radical transformation. The end of time, if it exists, might be stranger and more mind-boggling than anything we can imagine. So, there you have it, a whirlwind tour of the cosmos and the mind-bending mystery of time. We've explored the possibility that time began with the Big Bang, that it might be an illusion, and that it could even end someday. Time is one of the greatest mysteries of the universe. It's not absolute, it flows differently in different places, and it may have started with the Big Bang, or it might be an illusion. The more we learn about time, the more we realize how little we actually know. So, did time truly begin, or has it always been there? What do you think? Drop your thoughts in the comments, and hit that subscribe button for more mind-expanding videos about space, time, and the mysteries of the universe.